Good morning, everyone. Paul from the innovation community here. Today, I'm with Jan Teichmann, and having been working in a wide array of innovation, data, and insights roles, he now helps Trainline adopt their approach to data science. Great to have you with us, Jan.
Yeah, thank you. Likewise.
I gave you an executive summary there. Tell us a bit more about yourself.
Yeah, I mean, I'm 33 years old. I'm German from a city called Leipzig, but I moved to London over 8 years ago, previously living in Copenhagen. I guess, yeah, I'm a data scientist and a big technology and innovation geek. I think that describes me best. I, as you said, work as a consultant now, and I try to help companies to bring data science into like commercial production usage at scale, with sometimes success, not always success. I guess we get into more detail about that later. I guess as far as my bragging rights go, I mean, I hold a PhD in mathematics. Guess that makes me a smart cookie. I co-founded a startup after my PhD with friends, which saw a successful exit, and Anychange is now the biggest utility comparison and switching service in Japan. I, funny enough, feature in a documentary called Data Science Pioneers, but it's quite obvious that I'm not really cut out for a Hollywood career. I was also recognized this year as like a data titan on Data IQ's list of the 100 most influential data analytics practitioners. And yeah, so I think that's me.
And you mentioned that startup. Was that really where your career in data science started?
To be honest, no. As like an early day data scientist, I think it's quite common that my career started very much with an academic background. So I've really first discovered my preference for mathematics and statistics already during my undergraduate in biology, and went very much into like a modeling direction. And then later, I kind of followed that up with like an interest in computing and computer science during a master's in bioinformatics in Copenhagen, heavily working on like genetics problems, applying computer science and algorithmics to solving these problems. So it seemed like a logical step at that point then to combine these interests and basically apply computer science to solve maths and statistics problems. And then basically, yeah, I finished my academic career like many people, and co-founded my startup with friends and basically developed data science solutions for the utility sector. But it was really like already many years in academia where I basically applied data science to problems, but not in a commercial setting. That really has changed with that startup. And after that, I started to build greenfield teams at big PLCs and head up their kind of data science teams.
That's fantastic. And how has that changed to, from there to now?
Yeah. Funny enough, as I became more experienced and more senior in my roles, I very strangely did less and less data science and more PowerPoints, and also being exposed to quite a lot of corporate politics. And unfortunately, for like most companies which aren't Google, Facebook, and Amazon, data science is far from a success story. Surveys by Gartner over the years found, for example, that like up to 80% of all data science projects fail to see any business adaptation. And a big part of this problem is the difficulties of deploying data science into production, and a lack of good engineering skills in the data science field. And obviously the corporate politics preventing a lot of transformational change, like automated data-driven decision processes. So based on that, I mean, I think I was always motivated more by the technology rather than the scientific details. It's a reason I left academia. And I really discovered real-time applications as like my new passion. And is also the reason why I now became a consultant to help companies to get data science into production, but really with a focus on real-time applications of data and models.
That's really interesting. What are you up to in your current role?
So I'm a consultant at Trainline, doing exactly that, trying to help them with their production pipeline for data science models and data innovation projects. I do build heavily real-time data products where I basically focus on both, right? The productionization of data science models on Trainline's Kafka data platform, as well as turning data science models into data products for them.
So you've been in this space since leaving academia. What really interests you about working in the data space?
Um, as I kind of alluded, I really like the technological side of data, and really working with data means working at the cutting edge of technology. When you look at the last 10 years of like technological evolution, right? Data was always at the forefront of driving it, whether it's like cloud computing, distributed, big data frameworks. Now you run big Spark clusters in the cloud as a data scientist. Real-time data streaming and stream processing, NoSQL technology, all of that. And today you basically have platform as a service, which allows you, like as a data scientist, incredible productivity. I mean, I personally run workflows which used to require entire IT departments. So the real interest for me working with data is that you work at that cutting edge of technology.
So you mentioned a couple there, but what are some of the other successes you've achieved throughout your career?
Um, yeah. So, I mean, as I said, like the startup I co-founded with friends is now the biggest utility switching service in Japan. That's a major success. And when I was the head of data innovation at Rank, for example, I delivered a cutting edge cloud platform for them to host their data science models, which the data science team has built for the company. And that platform was the first project at Rank which was delivered on time and on budget as far as anyone could remember. And crazy enough, that platform is still running 2 years later. So I think that's a really big success. um, at at Supla, I saw analysts join, for example, my team of data scientists, and who have now really exciting data science careers, building amazing machine learning models, for example, for fraud detection and financial services. And as I said, me and my team also featured in that data science documentary called Data Pioneers. So that was a great success for the data science team at Supla. I I presented my data science production platform design at EGG last year, and that must have been in front of a few hundreds of people. So that was also quite remarkable. And when I think about it, my blog on Medium reaches over 15,000 readers every month. So that's I think these are all quite impressive lists of major successes.
Yeah, absolutely. And you mentioned a couple of organizational transformations there. What role do you think that ethics has to play in when companies are trying to expand their data science program and their general usage of data, let's say?
Yeah. Oh God. Yeah. So the reality is we live in a really heavily biased world. And, ethics, data privacy, and fairness are increasingly on the list of priorities of companies and also society to address it. But the main challenge is that historic bias means that achieving things like algorithmic fairness is much harder than a lot of people think. Every data point which is directly or indirectly derived from human behavior is biased. And depending on the definition and authors you reference, there are between 17 and 104, I think, documented cognitive biases. So it's a really big problem. I think when I look at the role of data science in that, fixing the bias in the world is obviously beyond the job specification of a data scientist. But not to reinforce existing biases automated with machine learning models is a mathematical problem, and it moves very quickly from like a moral obligation to a real job requirement of a modern data scientist. And I mean, yeah, fairness and mitigating bias is a really complex topic, and I'm certainly not an expert on it. But in the biased world we live in, we have the challenge in data science that mitigating that bias impacts model accuracy, and that we look at this accuracy versus fairness trade-off dilemma. And it is therefore that it's an interesting problem and conversation to have within the data science community, but also with the kind of senior leadership of companies.
And what role will technology have to play in this?
In mitigating bias,
because it's something that's been spoken about quite a lot right now. Is how that can actually help with like recruiting and actually getting away from that strictly human approach, for lack of a better term.
So I don't think that there are silver bullets, and that that even academia has really figured out a way to like approach this at a generalized angle. And as I said, I'm really not an expert on this. I just realize more and more how important it is, and how, maybe it is naive to assume that technology alone will solve that problem, right? In the end, it is down to data scientists and corporate leaders to really educate themselves on the problem and start to work on solutions. And it is really still early days. A lot of the kind of experts on that field and the material you find is very academic, because when you look at like regulation, for example, there is regulation on data privacy, but there isn't really much of a legal framework or guidance through regulation on this kind of problem of algorithmic fairness and debiasing. There are industries which are strict regulated, like financial services and insurance. I haven't worked much with these in these industries, so maybe they are like ahead of the game there, and they should really like share more of their learnings, because it is important that the field of like data science, but also companies start to get on top of that, so we avoid not just very public obvious scandals, like Cambridge Analytica, but for example, when was that? I think it was 2018 when Amazon tried to release an AI for recruitment. And basically, machine learning has this terrible problem with bias. So they trained their AI on CVs of engineering applicants and benchmarked it against like current engineering employees at Amazon. And basically, when you bring it down to it, this AI learned that candidates who are white and male are more likely to be good candidates for engineering jobs, right? That's terrible. So, they killed off this AI, and obviously it was never used after they found that. But it's like this is just shows that technology alone is not going to be the solution to that problem. If Amazon doesn't get it right, then this is a really tough problem to solve.
Yeah, yeah, that's a really good point. That technology can help, but it's not the silver bullet. I like the phrase that you used as well. What was just going back to your career? What do you think was the biggest impact that you made on a transformation?
Let me think about that for a second. I mean, I think, to be honest, when I look at it, at Rank and Supla, I've built greenfield data science teams, and every single project we worked on was therefore like transformational by definition. There wasn't data science before that, and improving a business process or a customer experience with a data-driven predictive solution is really transformational for these companies. But while I say that, naturally in that situation, you start with low-hanging fruit, and many early applications in like greenfield data science teams might just be forms of automation. While these projects aren't really the most sexy application of data science, shall we say, they have huge impact. And when you look at automating a process, that means, for example, less human errors, better quality and more comparable results. But really importantly, you rarely automate the people out of their jobs, right? These people simply have more time to add now new incremental value to the business. So automation is actually probably the most impactful transformation there is.
And you also mentioned that you work quite a lot with building these teams. How would you describe your leadership style when working with them?
I mean, like in terms of a leadership style, I don't really see myself as a leader or had a specific ambition to lead people. I mean, how could I possibly lead, right? To quote Isaac Newton, what I know is a drop, what I don't know is an ocean. And but I think, however, how I see it, it's like data science and technology is not just a job for me. They are my passion, it's my hobby. And all I ever did and still do is to share that passion with people. And I like to share my experience and learn from others, by connecting through the tech and data science community. And apparently that qualifies as a form of leadership.
I think so. I think I'd rather follow someone who's passionate than someone who doesn't want to be there. What do you think the biggest mistake you made during your career was?
Oh, okay. I think any success, right, is built on a long series of mistakes and failures. The secret is to try again. So that's the same for me. I have a long series of mistakes and failures to look back on. And I guess in the beginning of my commercial career, I made the general mistake to trust models are accurate and reliable in their predictions rather than to like mitigate the risk of a wrong prediction. I mean, data science predictions are never 100% accurate. So that, you can imagine, resulted in some costly mistakes when I, for example, developed trading algorithms during my startup days. Later in my career, I made the mistake to maybe highlight the flaws of data and the uncertainty of predictive models too much, which, for example, stopped the business adaptation of some really great machine learning models and made stakeholders doubt my ability as a data scientist. So yeah, it's a constant learning curve.
Absolutely. And a company like Trainline, Zoopla, these are all very digitally agile companies, I would say.
Yeah.
How has COVID-19 really affected your role and your ability to execute on a day-to-day?
I mean, as a data scientist and the impact of COVID-19, I wonder one thing. And that's what happens, to the predictability of all our historic data. A lot of that big data is behavioral data, right? Clickstream data, etc. Fact is, consumer behavior has completely changed. And there are reasons to believe that this change is much more permanent than some people might hope. So is all our historic behavioral data now worthless? Can we just all delete it? I mean, it certainly saves on storage cost. So yeah, that's a really interesting situation to be in, and I do wonder about this. How COVID-19 has affected my personal role. Not very much, to be honest, because I do work now on longer term innovation projects which have a much more heavy engineering focus than necessarily the kind of data science focus. And as you know, in technology and engineering, people work mainly in the cloud and collaborate digitally, so nothing really has changed. And yeah, but at the same time, I do have friends in the field who are very much affected by a sharp drop of revenues, because let's face it, data science is not cheap. And at the same time, you also see sharp drops of traffic to their websites, which means it's very hard, for example, to run a meaningful A/B test while that traffic volumes are so low. So there have been obviously impacts.
And I think not only is the historical data, but actually making sensible predictions on, how much is it, how permanent is it, or how much it's going to affect the future is also tricky as well. Just last few questions now. What was the best piece of advice you ever received?
I guess don't overthink it. I think this is like an interesting dilemma when I came out of academia, that looking at a problem with an academic mindset basically makes you very much focus on technical metrics of accuracy, for example. But when you are in a commercial setting, the proof of value is much more important than the proof of concept. And it's basically, that's like why I'm also now trying to help data science teams to turn their models into data products, because it's something which doesn't come necessarily naturally to a data scientist, to accept that actually a model just needs to be slightly better than chance to have a commercial impact, So sometimes it's important not to overthink it and understand that you build a commercial product, and you should focus on the proof of value to a business rather than technical metrics of accuracy, for example, and try to fine tune them and overthink how you can make your model better when actually it is good enough.
What's your top working from home tip?
Oh my God. I mean, very good question. I don't really think I'm the one who should give these tips, because when I look at, I had like a routine and all of that, and with the lockdown and working from home, all of that went out of the window. And interestingly, it's not because of the working from home. I'm quite experienced with working from home. It's probably the totality of the current situation and all the restrictions. But I am trying with a lot of willpower to establish a routine again, and try to wake up earlier again, to maybe start my day with a little bit of with a form of exercise, try to properly get dressed from the waist down. But other things are like try to collaborate again more digitally with colleagues who are not so used to digital collaboration. Try to not work till 9 p.m. every day and try to get a life back. All of these are really good general advice for working from home. Establish a healthy routine which has a balance of work and life. And yeah, that's my advice. Not that I'm really good in leading by example there.
Well, I mean, if you want to keep working on data, you could always pick up some Python projects, I guess. Yeah, that could be like your free time. That's a good way to do it. What are you curious about right now?
I think I mean I am quite curious about that topic of algorithmic fairness. As I said, I'm far from an expert there, but I think it will be the next GDPR, just by the long series of very public failures when it comes to working with data and do it ethically and fair. And I think we have to come to terms with the impact, blindly extrapolating bias in the data has on people's lives. So I'm quite curious about how this will evolve, how it will shape the way of working of a data scientist, the setup of data science, commercial data science teams, etc.
Who is currently your favorite thought leader or author, in or out of data?
Yeah, I don't know. Maybe that just shows that I'm terrible in giving credit. But in my early days as a data scientist, in particular, Alan Friedman and Ted Dunning really inspired and shaped my thinking. And it's because they're not just really amazing data scientists. They also share that passion for technology and with me, and are amazing engineers and solution architects. So I think what we need to recognize is that, we do stand on the shoulders of giants in data science. And I guess, Alan and Ted are certainly deserving that title.
And what advice would you give for aspiring data scientists?
I mean, the role of data science is changing. There's a constant innovation in that field, right? So it is, and it's very different now to become a data scientist than when I started on that career. So just looking back, at the last few years. In the early days, the role was for unicorns, right? I mean, every one of us is familiar with that Venn diagram of data science being that intersection of computer science, mathematics and statistics, and domain and business expertise. And that's also why a lot of the early data scientists came from an academic background, because they might lack business expertise, but at least, they brought the background in computer science, mathematics, and statistics. I guess as a consequence, early data science was heavily R&D focused, and we were focusing on technical metrics of accuracy over the business impact and ROI. And then obviously, as I talked before, you had the problem that there wasn't really business adaptation or business impact. Today, this has changed a lot. Rather than looking for unicorns with all these skills, companies actually see data science much more part of a cross-functional team where the skills are combined via good collaboration of data science, engineering, and product teams. And at the same time, the open source community has produced an endless number of high quality frameworks and tooling. So building a machine learning model doesn't require an academic background in mathematics and statistics any longer. What I personally observe is that actually the role of the data scientist is increasingly owned by advanced analytics, with data scientists itself moving more into that intersection of computer science and statistics with the rise of the machine learning engineer. And it really just shows that the focus today on engineering is just a realization that the production rollout of models is really the hardest problem in data science. So to sum that up, you really, as an aspiring data scientist, either look at the kind of advanced analytics realm, or you really should start to look more on the kind of engineering challenges with like production deployment of models, etc. I don't think that everyone needs to become an engineer, but it certainly has a growing importance in a successful data science career.
So broaden your horizons, wise words there from Jan Teichmann. Thanks so much for joining us.
No, likewise, was my pleasure.